Imagine London, March 1860. You're standing on a busy street near the New Road, today's Marylebone Euston Corridor. Horses scream, shopkeepers shout, and then the ground opens up literally. A trench wide enough to swallow the road is being dug right through the city, because a group of engineers has promised something that sounds insane for the 19th century, a railway under London, built before the city had modern electric power on site. If they fail, they don't just lose money. They risk collapsing streets, rupturing sewers, and burying workers alive. And yet, less than 3 years later, Londoners descend underground and ride the world's first underground passenger railway when the Metropolitan Railway opens on January 10th, 1863. To understand how they pulled this off without the electrical world we take for granted, you have to see what really happened. The first truth is uncomfortable. Without electricity doesn't mean without technology. It means without the electric ecosystem that powers modern construction. No site-wide electric motors, no LED work lights, no electric excavators, no automated ventilation, no digital surveying. What they did have was a brutal, effective Victorian toolkit. Human muscle, steam, gaslight, rope and pulley rigging, and, later in the century, hydraulic power and compressed air and tunneling shields. The underground was born from a world that still smelled of coal smoke and hot iron, where progress arrived as a clang of hammers, not the hum of transformers. Picture the city pressure cooking by the mid-1800s. London is swelling with people, and the mainline railways have dumped their stations around the edge, Paddington, Euston, King's Cross, while the city of London, the financial heart, remains a choke point. One plan maker who refuses to let it go is Charles Pearson, the city solicitor, pushing the idea of an underground railway to connect the termini and ease the crush above ground. He doesn't live to see the opening. He dies in September 1862, just months before the first trains run. But his pressure helps turn an impossible proposal into law and steel. Now the engineering decision that makes everything both possible and terrifying, cut and cover. Not a deep tunnel bored far below foundations. This is Victorian blunt force. They dig a trench from the surface, build the railway structure, then roof it over and restore the street on top. It's fast compared with deep tunneling, but it turns central London into a long, jagged construction wound. The Metropolitan's first stretch is about 3.75 miles, 6 kilometers, from Paddington to Farringdon, and construction begins in March 1860. If you could lean over the edge of the works, you'd see the geometry of the trench, around 33 feet 6 inches, 10.2 meters wide, with retaining walls of brick, and then a roof formed as an elliptical brick arch or supported by iron girders spanning about 28 feet 6 inches, 8.7 meters. You'd hear shovels biting gravel. You'd hear the metallic tattoo of picks on clay. And over it all, the heavy, rhythmic chuff of steam equipment. Because when you don't have electric machinery, steam does the heavy lifting. SO who actually builds it? Not executives in top hats. Navvies. Thousands of them. The London Museum's account of the District Line works describes how, by 1866, the District Railway employed 2,000 navvies, many coming from Ireland and Scotland, known for being strong and hardened by earlier canal and railway work. Their lives are mud, noise, risk, and pride. Imagine standing in fog that numbs your fingers, hauling spoil, while steam cranes groan above you and the city keeps moving, impatient, right at the trench edge. For the men doing the work, every day is a wager. Your wage versus the ground's mood. Here's the part people forget. You don't just dig. You must get rid of what you dug. London's excavation produces mountains of spoil, and much of the work is manual. The Metropolitan job uses navvies and even a primitive conveyor system for soil removal in places. Because a trench can't just fill up. You must keep the face moving, or the whole project suffocates under its own waste. And while your hands are doing that, your lungs are negotiating dust, smoke, and damp air. But how do you build a tunnel roof without modern plants? Brick. Endless brick. The London Museum notes temporary kills at Earl's Court, baking an almost unbelievable figure. 140 million bricks for the district works. Try to visualize that. Brick after brick, warm from firing, stacked like a second city being built beneath the first, while steam-powered cranes swing loads overhead. Chains clinking, hooks squealing, and foremen shouting through coal haze. And then come the systems you only notice when they fail. Water and sewage. London sits on layers that can punish mistakes. and Victorian infrastructure is already strained. The Metropolitan construction record includes multiple incidents, events that feel like previews of disaster. In May 1861, an excavation collapse at Euston damages neighboring buildings. In June 1862, after heavy rain, the Fleet sewer bursts and floods the excavations. Imagine the sound. First a crack, then the roar, muddy water hammering into the works, lamps sputtering, men scrambling up ladders, boots slipping on bricks slick with sewage-tainted flood. The city above barely understands what's happening below until the streets start to sag. And it's not just the ground. The railway world itself bites back. Wikipedia's Metropolitan Railway history notes that in May 1860, a train overshoots at King's Cross and falls into the workings. Later that year, there's a boiler explosion on an engine pulling contractor wagons that kills the driver and his assistant. No hard hats as we'd recognize them. No modern safety culture. Just Victorian industry's quiet rule. The schedule is sacred and the men are replaceable. While executives count capital, workers count fingers, and friends who didn't come home to SO what is without electricity look like inside an early underground project. It looks like gaslight, not floodlights, yellow, trembling illumination. It looks like muscle and leverage, crowbars, wedges, timbering. It looks like steam power, cranes, hoists, pumping, hauling. And it looks like ventilation as an afterthought, because even the finished railway is about to reveal a new problem, underground smoke. When the line finally opens to the public on January 10th, 1863, the Metropolitan runs with gaslit wooden carriages hauled by steam locomotives, and passengers show up in huge numbers, about 38,000 on opening day. The air issue is immediate and notorious, but curiosity and necessity override discomfort. London has traded one kind of congestion for another. Not carts in the street, but smoke in a tunnel. And here's the contradiction. One of the most Victorian contradictions of all. Progress, delivered by steam, choking the very space it creates. The first section costs about £1.3 million and includes not only cut and cover, but also a key, deepish segment. A 728-yard, 666 meters, tunnel under Mount Pleasant. Trial runs begin even while construction is still underway, and by May 1862, there's a full-line trip with guests, including William Gladstone, a political figure literally riding through a worksite that, months earlier, could still collapse or flood. Think about that. The tunnel is both a construction zone and a national spectacle. What happens next would change everything. Because now other lines want to end up by the 1880s. The underground has formed a rough circuit around central London, pushing into suburbs, yet the core problem persists. Crossing the city is still hard. But cut and cover has become too disruptive and expensive for new routes through the densest areas. So engineers look deeper into the clay beneath London, toward the idea of the tube. And this is where the story shifts from trenches in daylight to cramped, pressurized darkness. Deep tunneling under London doesn't begin with trains. It begins with a dangerous obsession. Tunneling under the Thames. The Thames Tunnel, designed by Mark Isambard Brunel, starts in 1825 and takes nearly 20 years to complete, opening in 1843. Brunel's key invention is a tunneling shield, meant to protect workers as they excavate through soft ground. But even this protected work nearly becomes a mass grave. In the worst flood in 1828, 6 men drown and the project stalls for years. That's the hidden price tag of the underground's future. Paid decades before the first tube train exists, so ask yourself. After that, why would anyone go underground again? Because the city above is becoming impossible. Because investors smell profit. Because engineers keep iterating. The London Transport Museum explains how William Peter Barlow conceives a circular shield idea, but it takes his former apprentice, James Henry Greathead, to turn the concept into something practical. Greathead's breakthrough produces a tower subway, opened in 1870, a tiny tube under the Thames, only 7 feet, 2.13 meters wide. Think about that width. Imagine being inside, hearing the scrape of tools against clay, feeling the damp cold river above you, knowing one mistake could turn the tunnel into a drowned corridor. The Transport Museum's Victorian underground story gets wonderfully specific about how Greathead's early shield method works. A small circular shield, Miners removing soil by hand. The shield shoved forward using powerful mechanical force. Described there as being pushed onward by large screw jacks, then the newly excavated section lined with cast iron segments to form a cylinder. No electric TBM. No computer-guided laser alignment. Just a disciplined cycle of excavation. Push, line, repeat, like building a metal spine through clay. And then comes the irony that complicates your title. The deep tube becomes possible because of electricity, not for digging, but for trains. The London Transport Museum notes that the crucial development in the 1880s is a clean, efficient, and reliable source of power, electricity, enabling the City and South London Railway, CNSLR. That line opens in November 1890, running between King William Street and Stockwell, in two tunnels about 3 meters in diameter, with hydraulic lift stations to move passengers between street and platform. Greathead improves the shield by adding hydraulic power and even uses compressed air, not the modern electrical grid, but pressurized force and fluid power, doing the pushing where muscle can't. So here's the real answer to without electricity. The earliest underground is built and expanded through a hybrid Victorian energy world. The metropolitan and district era relies on cut-and cover, bricks, steam cranes, manual excavation, and gaslight. Deep tunneling evolves via shields pushed by mechanical and hydraulic means, with compressed air assisting. And only then does electricity step in, not to make construction easy, but to solve the ventilation problem that steam trains underground could never fully escape. For people riding today, the underground feels inevitable, just another map, another escalator, another delay announcement. But nearly a century later, the Transport Museum points out that modern tunneling machines still follow the shield principle Greathead established in 1870. It even gives a jaw-dropping modern-scale comparison. For the Elizabeth Line, 8 tunnel boring machines, costing about £10 million each, dug 42 kilometers of tunnel between 2012 and 2015. Now compare that to a hand-driven shield and cast iron rings. Advance one relentless increment at a time under Victorian London. Same principle, different century, different price paid. So when you hear constructed without electricity, don't imagine a quaint candlelit project. Imagine a city cut open with trenches 33 feet across. Imagine 140 million bricks baked near the works. Imagine collapses at Euston. Floods from a bursting sewer, a train dropping into the excavation, a boiler exploding. Imagine navvies, often migrants, living hard, working harder, building a machine beneath the streets that would reshape London forever. And imagine the planners, Pearson, engineers like John Fowler, appointed engineer in the early planning stage, and Greathead, pushing ideas forward while the ground itself tries to push back in the end. What was achieved is simple to state and hard to absorb. The world's first underground passenger railway opens in 1863, and London becomes a template other cities copy. But what was lost is harder to quantify. Disrupted neighborhoods, demolished homes, and workers whose names never made it into celebratory speeches. The legacy still surrounds you. Every time you step onto a platform, you're standing on decisions made when steam was king, when gaslight flickered on wet brick, and when safety margin often meant hope. Today, we argue about funding, delays, and modern megaprojects. Yet in the 1860s, they were inventing the rules while digging the proof. The London Underground still stands today, built on brick, iron, steam, and human endurance. As modern cities dig deeper for new lines and faster links, this story reminds us that infrastructure isn't only concrete and steel. It's risk, labor, and the choices society makes about whose lives they spend to keep everyone moving. The question now is, when you ride underground, do you see only a commute, or do you see the buried city of work beneath your feet? Share your thoughts below.